let's get started. Let me also mute this. Okay, wonderful. Yeah, very warm welcome to all of you. My name is Sebastian Goldt. I'm one of the organizers of this little workshop and little experiment, I should say. Right? It's the first time we are organizing this kind of event here at STP. We've organized many events at STP. I think this is the first one with such a really interdisciplinary crowd. So, of course, I'm not the only organizer. In fact, I'm part of a very huge team that's done a lot of work over the last couple of months, almost a year now, I think, in putting together this conference. I want to particularly highlight the three students who really did actually most of the work and who will be happy to answer all of your questions. I don't know anything. Okay, so Lorenzo, Elisa, and Fabiola, who are all here in the first row. Elisa will say a few words in a second. Okay, so let's start with some very simple questions. Okay, so where are we actually? We are in a very nice city of Trieste, here on the Adriatico, right on the border to Slovenia. So very interesting place, very interesting history. Don't worry, I'm not going to go into any detail on that. More specifically, we're at the International Center for Theoretical Physics. Okay, and this is a very particular place. It's a research institute focusing on theoretical physics, or at least traditionally, right? It just celebrated its 60th anniversary, but it's a very particular research institute, okay? So it's under the tutelage of UNESCO, and its mission really, besides doing world-class research in theoretical physics, is to do some sort of capacity building in physics throughout the global south, okay? And it does so through many activities. First of all, there's an international master for students from the global south, a one-year sort of master program in physics, in different branches of physics that's really high level, that prepares students to go on to do PhDs, careers in industry throughout the world. And there's many more outreach programs, schools that it organizes. And there's workshops like this one where it tries to build bridges between communities. And so I think that's a really inspiring mission. I'm not affiliated with STP in any way, so I think I'm allowed to say this. That's the easy part, okay? Already a bit harder is maybe the question of why are we actually here? Okay, and I think all of us have kind of their own little story, what brought them to this field or to this workshop. For me, it's really nicely encapsulated by this little quotation. Okay, so when you go to EPFL and you get out of the metro station, okay, you go through a corridor with very inspiring quotes from science, some formulas, and this quote here: "Science is what we understand well enough to explain to a computer. Art is everything else we do." Okay, I think in this form it's attributed to Donald Knuth. I think the idea goes back way longer to Ada Lovelace. And I guess in very simple terms, the reason why we're all here is because we're all wondering, is this actually still true? Right? Is this demarcation, which sounded very nice maybe 10, 15, 100 years ago, is it actually still true today? Okay? And why are we asking ourselves this? Because in the last few years we've seen this boom in machine learning, in artificial intelligence, and in particular in generative AI. No, we can now generate photorealistic images, even videos from a simple textual prompt. We can, of course, also generate text. We can converse with these machines. And we can make music. I don't know if you've tried this, right? You can write a prompt about the song that you'd like to hear, and you'll get it. It's pretty amazing stuff. And I think naturally when you interact with these technologies, you ask yourself, okay, what is going on? And then after a while, actually, is this thing really doing creative work? Okay? If you think, for example, about the diffusion model, right, you can ask yourself, is this actually really a computer program, right? What does it do? What it does is actually fairly simple, right? If it generates an image, it takes noise, okay, so just some completely random pixels. And what it's learned is here in this neural network a way of transforming this completely random thing, this noise, into an image of, in this case, a cat, or more generally speaking, into an image that looks closely or is somewhat similar to the images that it saw during its training process. Okay? So what it really does when it's learning, when it's training it, right, it takes many images of other cats, okay, and what it observes is sort of a slow degradation process, right, a slow descent into decadence. We add more and more noise to the image. We observe this process, and then we try to learn how to reverse it, right? So in other words, given any of these noisy images, we try to learn what was the original image. Right? It's called denoising, right? It's a very fundamental operation in computer science and image processing. And the fascinating thing is that once you've learned how to denoise an image, you can actually sort of start denoising noise. Okay, so you start with a pure vector of noise, and then you sequentially denoise it. Oops, how can I start this? Maybe like this? No. This was supposed to show you a video of... Well, I'm sorry, this doesn't work. Well, in this little video, what you can see, was how successively the model takes the noise vector, denoises it, and by repeating this operation, ends up at an image of a new cat. Okay, or at least that's what we would hope. So, is this a computer program in the sense of the definition, or of the quotation, I should say, that I showed you in the beginning? I guess it's a bit complicated, right? At a very sort of simple level, yes, this image generation engine, it's a program, I'm running it on my computer, right? It's a simple pipeline. But there are a few ingredients here that make this a bit more subtle, maybe. First of all, there's a lot of randomness that goes into this computer program, right? And I'm not just talking about the noise here that we're starting from, right? I'm also thinking about the data set that the model has seen during training, right? This is a sort of random collection in the sense of images that people mostly scrape off the web without any particular concern where they come from. And it's certainly not, maybe the most faithful representation of the world. There's other sources of additional sources of randomness during the training. Maybe some of the talks will go into that, right? There's the question of where do you start from with your network? In which order do you see the image? What's actually precisely your training objective, right? What's precisely the program that you're following to train this model? And the important thing here is, I think, that the impact of all of these factors on the final model is very hard to predict. Okay, I think you can make an argument here about what you can predict with sort of infinite computational power or infinite knowledge or infinitely precise measurements. But let's say for any practical purposes, we have no clue of how to predict what kind of model we're going to get at the end of this training procedure. Okay. Finally, that's not the only kind of creative computer program that's floating around the ether these days. Another one that you all know, of course, are the language models. Okay, which everybody's now sort of probably played with a little bit. And here the idea is, again, very simple, okay? So here, we're not trying to learn how to denoise text. Instead, what we're trying to learn is how to predict missing parts of text, right? So for example, if I show you, for the Italians at least, famous beginning of a novel, right? Quel ramo del lago di. And then I ask, okay, what's actually the next word in this piece of text? And everybody, I hope, knows that we're talking about the Lago di Como, okay? And what these neural network models now do on a very, very big scale is just play this game with every bit of text that's ever been uploaded to the internet, okay? So this very simple idea and, brute force calculation in a sense in terms of the amount of data that you use for this kind of game, the amount of compute that you use for this game, gives you these models like ChatGPT. Okay? When I say a lot of compute, I really mean a lot, right? You've been probably following this in the news, this battle for these computer chips. You can also read it off in the valuation of the companies that actually produce these chips. But again, I think the question here is the same, right? Okay, this is somehow a computer program. Again, there's many sources of randomness in the type of text that it saw. We'll talk later about some subtleties in the generation of the text once you have such a model. But still, the question is, okay, are these models actually creative? And so, to actually discuss this, I think you need to go beyond the mere technical details of these architectures, right? You need some understanding of actually what it is to be creative, what that means, which entities can be creative. And that's something that me, myself, as a trained physicist, or my colleagues who are working in machine learning, are maybe not best equipped to do. Right? For this, what would really be useful is if we could talk to somebody or to a field that has thought about these things for something like 2,500 years. And so that's kind of what we want to do in this workshop. And so now Elisa is going to complement sort of the technical introduction with some comments on the philosophical frameworks. So you're just going to need to take this. I put it here on your...
Okay. Good morning, everyone. It is a great pleasure to have you here and to be able to share with you these 3 days of reflection. And before we begin and give the floor to the speakers, I will take 10 minutes to give you a general overview of the topic of creativity. Without claiming to be exhaustive, the goal of this introduction is to create a common ground of expertise between the humanities and the science. So the concept of creativity has changed a great deal through history, and therefore it is not possible to trace a unified definition. And without raising all the stage of changes that have marked off the conception of creativity, it's interesting to note how from the time to time, in addition to the nuance of meaning, the attribution to the entity that proceeded or exercised is also changed. Things, for example, of antiquity, creativity in the sense of making something out of nothing was viewed negatively because the concept of creation did not exist. In fact, art was seen as performing according to rules, and the artist as the one who reproduces and follows the rules. In the Middle Ages, creation ex nihilo emerged, but it becomes an exclusive attribute of God. With modernity, on the other hand, creation from nothing is transformed into producing something new, and the attribution of creativity shifts from God to the human being, and especially to the artist. The spread of the attribution of creativity proceeds until from the 20th century, where the idea appears that people active in other fields of human production, besides art, for example, in science, can also be creativity. So the question we address today concerns a further extension of the attribution of creativity, one that includes machines. So, in general, the notion of creativity in its contemporary version always includes two souls, that of novelty and that of value. Novelty is understood as something new and original with respect to previous productions or the context referred to value, on the other hand, understood as something useful and significant with respect to the artist's personal history or the history of humanity. In the history of contemporary creativity, especially with reference to computational creativity, that's that which is hypothetically present in machines, a key reference author is neuroscientist Margaret Bowen. In particular, she starts from this twofold division of the conception of creativity is the value of value and originality, and adds another element, that of surprise. She proposed a kind of taxonomy of creativity from the different types of surprise, distinguishing it into 3 different categories and assuming that they can also be exercised by machines. So, combinatorial creativity consists of creating unfamiliar combination of familiar ideas in a deliberative or unconscious way. Exploratory creativity proposes a new idea within a given conceptual space, and within the same thinking styles allows glimpses of novel possibilities. Finally, transformative creativity is the most deep case of creativity and occurs where someone manages to think of something that, with respect to the conceptual space of his or her own mind, he or she could not have thought of before. This impossible idea can only arise if the pre-existing thinking style is modified, radically transformed. Beyond Boden's position on the matter, I think it may be interesting to try to understand whether these types of creativity can be attributed to neural networks or not. So regarding the general overview of open question with respect to the relationship between AI and artistic production, I believe that the most fruitful point of observation is to start from the examination of the object. I think 3 different case histories can be distinguished. The first is the relationship of the art object to itself. Here one is questioning whether an artificial generated product can take on properties that either at an intrinsic level or at the level of a posteriori recognition allow it to be considered as art. As at the same time, the meaning-generating capacity of this object must be discussed. The second is the relationship the object has with those who generate it. This perspective opens up three different questions. The first has to do with the question, who is the author, and thus with whether or not we consider it a non-humanity entity as an author. This is not only a philosophical issue, but as we will see these days, also a legal issue. The second has to do with intentionality. Given that we cannot consider neural networks as conscious and self-conscious entities, are we willing to accept their creativity can be non-intentional? Finally, the third issue has to do with the experience, which in the case of human artistic production plays a central role and is closely related to having a body. The dataset on which neural networks are trained are extremely vast, but can they be compared to a limited and contingent experience, such as of a single individual? The third is the relationship that object has with external entities. This case can be examined from two perspectives. On the one hand, the relationship with the audience, the way in which the reception of the world changes as we discover that it is artificial generated. On the other hand, the relationship with history, thus the value and that an artistic product takes on in comparison with the previous cultural tradition. So I hope I managed to touch on that, at least some of the issues surrounding artificial generation and artificial production, and I look forward to hearing from you. So I think that Sebastian can talk.
Yeah. Yes. Wonderful. All right, so I hope that we sort of set the scene and sort of laid out a little bit the space in which we're going to move over the next 2.5 days. So just very briefly to give you sort of a heads up on the schedule, we printed some schedules which you can find at the entrance. Okay, we'll also keep our site up to date. So we'll have talks up until Saturday. At lunchtime, we'll always meet in here, okay? And then two things that I want to highlight in particular are, let's say specifically today, we'll have a little aperitivo as a sort of welcome to all of the participants of this workshop at 6:30 at Melograno, which is downtown in Trieste. I guess there's also going to be a group that's going to leave together from here and go directly to town, so don't worry about finding it. And then, of course, at 9, we'll have the concert. That we've communicated to you. I'm very much looking forward to that, and that's also going to take place in the city center, close to Melograno. Okay, so that's going to be very cool. And yeah, we'll close every day with a little panel discussion. You know, that includes the invited and contributed speakers of that day. We'll have a poster session. So really, lots of stuff to look forward to. Did I forget anything in terms of schedule or logistics? What? Okay, nothing apparently. Okay, very good. Before we start though, I'd like to give the words to Matteo, because we're also doing a little experiment in the course of this workshop, and Matteo is going to be able to tell us more about that.
Yes.
Do you want to connect?
Yes. So I have just one slide.
Okay. Oh, I think it's... okay.